Welcome to qnawire.
Hi, remember that for transitional metal compounds that contain d orbitals and that have an octahedral arrangement, the splitting of the d orbitals is the following. So we can calculate directly let me do it in another color, we can calculate directly what is going to be the energy of photons absorbed by this change of energy that we're going to have. This corresponds to the electron transition from going from one orbital to another. In this case, we're not given the information on the energies of the orbitals. So what we can do is take information of the characteristics of the compound. So in this case, whenever we have hexaamine cobalt ions, one thing that we can know is that this guy is going to be of a yellow color. That means that if the complex is yellow in color, that is the color that is being reflected, not the one that is being absorbed. And in order to know what is the frequency that is being absorbed, we need to look at the complementary color. In this case, the complementary color of yellow turns out to be something in between purple and blue. So this corresponds to a wavelength of approximately in between 400 to 450 nanometers. Another way to look this up and to see what wavelength is actually being absorbed, you can look at the absorption spectrum of this compound, but that need to be determined in an experimental way in your lab. So with the information that is given to you, that is all that we can know. Alternatively, if these values of energy is given to you, we know that delta E is equal to H times U, which is equivalent to Hc over lambda. So if the information of this change of energy is given, you can calculate directly the wavelength as Hc divided by the change of energy. Just being careful to employ the correct units. So that would be all. Thank you very much and have a good one.